I move quickly, which means it'll be a mini miracle if I don't make 10,000 mistakes. But here is the lesson on video 811-812, high octane sinusoids. Here we go. Example 1. Jenny has a spring with a weight attached, and she believes she can make the model a motion of a sine or cosine function. I'm going to give you a little hint. This, in my opinion, overall is your easiest option. They tell you down here to go ahead and use cosine to write the equation, so they already know you're going to have an easier time if you use cosine. I'll explain what I mean by that in a minute. But it says she starts the stopwatch and records the first highs and low points of the weight. The first high point is 46 centimeters above the floor when the stopwatch was 0.4 seconds. So this is 1 second. 0.4 would be right about there, and the height would be 46. I'm going to put it right there. And I'm going to list that as a point. 0.4 seconds, 46 centimeters. Then it says the next low point of 26 is at 2.2. So this is 3-ish. 2.2 is right about there, and they said 26 would be right there. So 2.2 and then 26. As you can see, they're trying to build a curve, sine or cosine. But if we notice from 0.4 to 2.2 is, well, it's exactly 1.8 seconds. So to finish the rest, we'd add 1.8 to this, which would take us to 4. And then we have this point here, 4:46. So a whole bunch pops out at us. So it says graph the sinusoid using the two known points on the graph. We did. Well, now it says find the function that this, in terms of cosine, captures. Well, we got to remember there's a whole bunch of letters that we need to be in control of, and here they all are. So we got to find the amplitude, we got to find the period, did it move right or left and up or down? Well, all of that happened. So let's get started. To find B, I like to go after that first. You don't have to, but I just do. I look at the period. It takes from 0.4 to 4. That's 3.6 is this cosine curve's period. Now, why didn't I say sine? Well, remember, in the world of sine, we know that sine goes through the origin. So we kind of have to identify where that point is. And on this picture, it'd be right there and right there. And that kind of throws us off into no man's land. But if I use cosine and I think about what cosine looks like, cosine goes over like this. So that point, that peak of the wave is right here. So we might as well talk about that. If this is the normal parent function, this peak got bumped over 0.4, which is this portion. So we can build that right now. It got moved to the right, 0.4. Now I said I was going to find B first, but that seemed like a natural little segue, so I took it. So let's find B. Well, we know the period is 3.6. So the formula, period, equals 2 pi all over the absolute value of B, but I'm going to leave the absolute value off. I already know what the period is. It's 3.6. So now I need to do some nifty math, multiply both sides by B, because I'm trying to find B. So I get 3.6B equals 2 pi. I'm going to divide by 3.6, divide by 3.6. I'm just going to say this, if this was like 2 pi all over 3, I would keep it, and I would put it right there. But because this is kind of messy, you can put it like this in there. But I'm going to go ahead and figure out what this is. Give me 2 seconds. I'm going to pause this. All right. So we're going to go 2 times pi, which is right here. And I'm going to hit enter, and I'm going to say divide by 3.6. I get 1.75. I'm going to round that just a little bit. So 1.75. So I'm going to put that in that spot. So I'm going to build this a little bit. y equals, still got to find a, and then cosine 1.75. We know it moved to the right 0.4, and now we got to find out those two parts, a and d. Well, remember, back to this drawing, the x-axis cuts the sine wave in half, the x-axis cuts the cosine in half. We find the amplitude by here or here. So we got to figure out what line cuts this in half and use some logic. Well, from 26 to 46 is 20. So that whole space is 20. But we only want this. This is the amplitude, or this. And that would be half of 20, which is 10. So that tells us that our letter A is 10. Now we got to find out, how high did the x-axis go? Because notice the x-axis is right here. It doesn't go up at all. So this is asking us to find that distance. Well, it's 26 to that point right here, and then another 10. So that'd be 36. So I got to put a 36 right in there. That ends problem number 1 from our note packet. All right, problem number 2. We got a couple of people. They're at a beach. I'm just jumping through this. The water rises and falls at a pier. They both start thinking the levels could be represented using a sinusoid. That's a word for cosine or sine. Remember I said lean towards cosine heavily, and I'm going to prove that over a few examples. The lowest level of the tide is 2 feet at 8. Now, it says, and they find the highest point is 40 inches at 2. Now notice they go feet and they go inches. Well, we got to convert feet to inches or inches to feet. Now me personally, if we convert that to feet, we're going to introduce decimals. So I'm going to stick with inches, and that would be 24 inches. Also, when they start giving you these times, and remember this one was in terms of seconds. That's why I went from 0 to 1 to 2 to 3 to 4. This thing is similar, but on these types of problems, they're not going to give you this hint down here. It says, write an equation to model the height of the tide relative to the post as a function of time, where t equals 0 represents 12 o'clock midnight. That's another phrase for 12 a.m. Now give me 2 seconds. All right, quite the mess, but let's try to hone this in. Write an equation to model the height of the tide relative to the post. So here we go. We got all this information. At 8 a.m., so remember this is 12 a.m., so 1, 2, 3, 4, 5, 6, 7, 8 a.m., they're telling us the height is 24 inches. So I'm going to go up to 24, try to keep some accuracy here. So that's 8:24. 8 hours, 24 inches. That's the low point. The highest point is at 2 p.m. So here's 12, 1, 2 p.m. So at 2 p.m., the height is 40 inches. Oh no, it doesn't say 40 inches. It says 40 inches higher. That word kind of snuck by me during the lesson today as well. But anyways, 40 inches higher. Well, 40 plus 24 is 64. So 2, I'm going to try to be somewhat accurate here and slide that over right about there. So that's 264. There we go. Thank you, Carter, for catching me today. All right, but remember that's half of our sinusoid. Now some of you might want to continue this way. It's not wrong. But remember, I said we want to try to use cosine. So we're looking for a peak. So I'm going to do some thinking here. Oh, another mistake. This is 2, but it's really 14. 14 hours. It's kind of military time, 1400 or 14. So I'm going to change that 2 to a 14. I'll show you why. This is half of the curve, so from 8 to 14 is 6. So I'm going to come back this way 6, taking me to 2, and then that takes me to 64. So that's actually 264. And notice if I complete that curve, it looks something like that. And I can see that that peak has been moved over 2. So if I think of this, y equals a cosine b x minus c plus d, I know what this piece is. It's moved over to the right 2. So I'm going to go x minus 2. Now I'm going to start building. I can see that the entire period is from 2 to 14, which is 12. So period equals 2 pi all over b, multiply by b, multiply by b. So I get 12b equals 2 pi, divide by 12, divide by 12. I get pi over 6. Now this is a nice, neat thing, so I'm going to keep it. Pi over 6, cosine. Now I need to find the amplitude. I can see from 24 to 64 is a total of 40. But remember, I want the halfway mark. So if this is 40, that means this is 20 and that's 20. And that's going to be my amplitude. And how far did we move this up? Well, we got to think for a second. We went up 24 to this point, another 20. That's 44. So there's D. All right. Now, they're going to start hitting us with some questions. And we're going to use this formula. And it says, at 11:30, well, let's think for a second. That's all the way to here. How many hours is that? That's 11.5 hours. That's what we're going to put in for x. You can use a t if you want. So we're going to go y equals, notice it says what's the height? Remember, that's our y-axis information. Keep all of that in mind while you're doing this. And then we get 20 times cosine pi over 6. We'll talk about that in a minute. X, we're going to put in 11.5 minus 2 plus 44. Now you got to remember PEMDAS. So we need to figure out what this is first. Now the question is, well, how do I do that? Well, this is easy, PEMDAS. 9.5. We got to multiply that by pi over 6. This is where I'm going to go to my calculator, and I'm actually going to go second pi divided by 6, because these are radians. That's 30 degrees, which is 0.52 of a radian, times 9.5, and that's 4.974. Don't round that too much. Cosine of 4.974. Now remember, these are radians, so check your calculator, make sure you're in radians, or else it's going to be a nightmare situation. So we're going to go cosine of 4.974. Now I can multiply that by 20. Then I can add that to 44. And that gives us approximately a height of 49.17, what did we say? Inches. That'd be our height. Now if we take a look at our drawing wouldn't be perfect, but look, 49, this is 44. So if we went to 11:30, it should be a little above that line, but it's not. But our drawing's probably not perfect. So anyways, we got close as far as the drawing goes. All right, now here comes an absolute thinker. I didn't get to this during the lesson today. So Bree's brother is 2 feet 7 inches. Remember, we're in terms of inches. So that's 24 plus 7. So his height is 31 inches. When is the first time after 8 a.m. that the water will be over his head? So what they're saying is let the height, which is y, be 31. So 31 equals 20 times cosine. Now this gets crazy. Pi over 6, back to the original, x minus 2 plus 44. So they're saying when? So they're saying find x. Well, notice, where is this? Well, if we think generically, it's cosine of theta. Now that's going to be interesting. Like, what the heck do we do with that? Well, watch carefully. First thing I'm going to do is subtract 44, because that's just jumping out at me. Let's clean this thing up. So I get negative 13 equals 20 cosine of this craziness. I'll just rewrite it one more time. X minus 2. Now we divide by 20, and I think I'm going to run out of space, but here we go. 13 divided by 20, negative, So we get negative 0.65 equals cosine pi over 6 x minus 2, and then we're stuck. Like, what the heck are we going to do there? Well, remember, guys, we're trying to find this. So if I looked at this generically and I went negative 0.65 equals cosine of some angle, how do we find that angle? Well, this is where we take our calculator, we go second cosine, negative 0.65, and it gives us 2.278. I'm going to call it 2.28. So theta equals 2.28, which means this stuff has to equal 2.28. That's new. I know that's new. So I'm going to convert this and then distribute it. So pi over 6 divided by 6 is 0.52. So I'm going to distribute 0.52 there and 0.52 there, so I get 0.52x. Then I'm going to go times 2, and that's minus 1.04 equals negative 0.65. Now watch this. I'm going to add 1.04, 1.04, so that minus 0.65, 0.397. So x is 0.397, and let's pause this for just a second. All right, caught myself in my first mistake. I sniffed it out. You guys probably caught me really early. Remember, we said cosine of theta is this, and then we found that theta was this, and what did I do? I put that in place of this and did my calculations, and I just sniffed something out. Carter, if you'd have been there, I know you'd have called me out on it. But here it is. Here's the actual equation. So I'm going to add 1.04, 1.04. I'll be right back. All right, so we took this out. We replaced it with 2.28, which is what we were supposed to do. Then we solved for x, and I got 6.38. Now remember, I've rounded a little bit, so this won't be perfect. But 6.38 is x. So that means at this time, after 6 hours and really 0.38 of 60 minutes, so what are we talking about? A little over 6:30, maybe 6:40, is the first time, you got to really pay attention here, that's when the height happens. And if we look at our drawing kind of helps. Every picture tells a story. 6:30-ish, we see the height could be around 31 inches very easily. But it says, when is the first time after 8? Now here comes some thinking. So if this is at 6:38 right here, 6.38 hours, that's when the height is 31. Well, that's the first time, but they're asking what's the first time after 8. We got to do a little thinking. So this is 8 hours minus this. So that's why I went 8 minus 6.38. It's 1.62 hours before 8. But because it's symmetric, it's going to happen again 1.62 hours after 8. So that would be 9.62 hours, but now we got to convert that to time. And so I took 0.62, multiplied it by 60, and I got 37.2 minutes. So it's approximately 9:37 a.m. That is a doozy of a math problem.